Classifying real numbers. After we put our heading up here, please make sure you put your period number. We're gonna just get into our examples. Let me read this. This past summer, Ethan spent a week at summer camp. He met several campers that could be described using the categories below. So we got 5 categories here of campers that Ethan met there at the camp, and starts with A is the same city, B is they came from the same class, C, they're from the same state, D, the same school, and E, they come from a different state. Using the graphic organizer above, place the letter of each category where you think it belongs. So which one would be the smallest group right here? Out of the 5 that I mentioned, which one would be the smallest group? Okay, we could say that B, whoever came from the same class as Ethan would be in the smallest group. So we put B in the middle, and then the next smallest group after the class, say they come from the same school, D would be the next biggest size. And then the next biggest group we would have from the same city. The next biggest size would be from the same state. And then a group that doesn't belong within these squares because it's outside of the state would be E, campers from a different state. Okay, so we've categorized them, and let's go on here. Ryan is one of Ethan's camp friends who is in his first period math class. List all the sections of the graphic organizer that Ryan's name could belong to. Okay, so they said that he's in the same class, right? So he belongs to group B, but because he belongs to the same class, he has to belong to the same school. So he belongs to group D also. And because he's in the same school, he's got to be in the same city. And because he's in the same city, he has to be in that same state. So he belongs to all 4 of these groups. And he would not belong to group E because, yeah, he wouldn't belong to any 4 of these groups if he was actually in E. If he was in a separate state, then he would just be in group E. But that's not the case here. He's in the same class, the same school, the same city, and the same state. Next question, which would be the best section to place Ryan's name in? Explain why. So let me give you a couple seconds to think about that. We could place him in 4 different groups, this kid named Ryan, but which group will we choose to place him in? So we're going to do the same thing with numbers also. We want to place him in the most specific group. So what's the smallest group? The most specific is group B. Group B because it is the smallest, most specific, not general, but most specific group he could belong to. And we know that if we put Ryan in group B, he has to belong to group D, A, and C. Okay, if he's in the same class, he has to be in those other 3 categories also. Same school, same city, same state. And moving on to some of these definitions here, any natural number is, well, the natural numbers are the set of all positive counting numbers, numbers on a number line starting with 1. Okay, examples would be 1, 2, 3, 4, on into infinity. The way I think of the natural numbers is if you go out in nature, okay, nature, natural, and you just count the objects you see, you're going to be counting 1, 2, 3, right? So if you go to the pond and start counting ducks, you start counting ducks that are swimming along in nature, you count 1, 2, 3, 4, 5 ducks, okay, but you're not going to be counting negative ducks, and you're not going to be counting 0 ducks. You can't see 0 ducks. You see whether there's 1 duck or 2 ducks, and it's all positive numbers starting with 1. So for example, if you're standing near an ant pile, you could count all the natural numbers of ants. You'd be counting 1, 2, 3, 4. You might be counting hundreds of those ants. Okay, but those are all natural numbers. 1, 2, 3, on into infinity. But then we get down to the whole numbers and the number set gets a little bit bigger. The set of all positive counting numbers starting with 0. So it's all the natural numbers, but we're just adding in 0. Okay, whole numbers, we have 0, 1, 2, 3, and so on. So all the positive numbers, all the positives including 0. And we're going to go larger here with integers. Integers are the set of whole numbers and their opposites. I hope I spelled the word opposites right. But yes. The set of whole numbers and their opposites. So we're going to have 1, 2, 3, but we're also going to have 0, -1, I'm running out of space here, -2, -3, -4, and so on. So all the positive numbers with their opposites, all the positives, negatives, and 0. And moving on to rational, the next biggest sets here, or the next biggest set, numbers that can be written as fractions. They are terminating decimals, so anything that ends, anything that terminates, like 1.5, like 2.5, those are all terminating. Repeating decimals, that means they repeat the same digit over and over and over again, like 0.44444 repeating is still a rational number because it's repeating the same digit over and over. And square roots of perfect squares. Let me highlight that. So the square root of 25 is 5, that's a rational number. The square root of 144 is 12, rational number, because those are perfect squares. All their answers are rational numbers. Okay, so what are some examples of rationals? We can have 12 1/4. We could have all sorts of numbers here. We could have -6.2. We could have 1.73. We can have the square root of 36, because that's a perfect square. And those are all examples of rational numbers. All these numbers, we could put them into fractions because they either terminate or they repeat the same number over and over. So those are all of our rationals. It's a big list of numbers. And now our final set here, and this set would not be included in the previous 4. Okay, this is its own group here. Irrational numbers, numbers that cannot be written as fractions. Excuse me for not highlighting. And they are non-terminating decimals, non-repeating decimals, and square roots of non-perfect squares. Non-perfect. Okay, so what are some examples of irrational numbers? We could put pi, which is 3.14159, going on into infinity. It's a number that's non-terminating, it doesn't end, and it doesn't repeat the same number either. It'll give you pretty much every number. Okay, let me make a list here. So we have pi, we have the square root of, say, 10, right? That's not a perfect square, that's a non-perfect square. That'll give you a non-terminating, non-repeating number. What else can we put here? We could just put some random decimal that doesn't repeat the same digit over and over. It gives us a long sequence of never-ending numbers. So non-terminating, non-repeating decimals, okay, those are irrational. What else can we put down? We could put 7 times pi, and we could put the square root of 3. Okay, it's a non-perfect square. It's going to give you a non-terminating, non-repeating number that you cannot put into any fraction. Okay, so that's irrational. Let me zoom out a little bit to make sure that you can see all the answers on this front side. Okay, and let's just turn it over to the back. And you'll be free to complete this on your own, but let me just walk you through the directions for number one though. Number one on the reverse side. Place the headings for each type of real number in the graphic organizer below, then write the following values in the box where they belong. So let's just label our real numbers together, and then you can place the values where they should belong here inside the graphic. So again, what was our smallest group? Our smallest group of numbers, the first one I mentioned was the natural numbers. The numbers that you could count in nature, like 1 duck, 2 duck, 3 ducks. Okay, what is the next biggest group? The whole numbers. And the whole numbers are all the naturals, okay, 1, 2, 3, but you're including 0 with that group. All the naturals, meaning those positive whole numbers, but also including 0 this time as a whole number. Our next biggest group is the integers, and these are all the positive whole numbers, including 0, and their opposites. So if you have a 1 here with integers, you're gonna have a negative 1. If you have a 9 here with your integers, you're gonna have a negative 9. So it's all the positives and negatives, including 0. Our next largest group is called the rationals. All the numbers that you can write as a fraction because they are terminating, they end, and they are also repeating. They could repeat the same number over and over. And therefore, we can write them as fractions. And what is the group that doesn't belong to any of these right here? It's still, they still fall under the category of real numbers, but our other category is irrationals. Numbers that cannot be written as fractions because they are non-terminating, okay? They never end, but they also never repeat the same number either. They give you a long list of numbers. Okay, those are the irrationals. So let's just do one example here. We could take from this group of 6, and where can we place that number? So let's take 16 divided by 4, or 16 over 4. 16 divided by 4 is 4. And where can we place that 4? What's the smallest, most specific group we could place the 4 in? Okay, we know that 4 is rational. We could put 4 into a fraction, 4 over 1. We know that 4 is an integer also because it's a positive whole number and it also has its opposite in there, negative 4. So we could put it as an integer also. We could put it as a whole number because whole numbers include all the positive numbers and also 0. But the smallest group we could put it in is the naturals because the naturals don't contain 0. So let's go ahead and write 16 over 4 right here because that's the smallest, most specific group. We can put that number in. Okay, so go ahead and try the rest of these right here on your own, and then you're going to go through number 2 and then finish the last few questions down to number 6. And if there's any questions whatsoever, any questions, please bring this to class because you have till Friday to complete this. And I'm happy to answer any questions you have about classifying these numbers. Thank you.